Hello everyone. So today I am going to discuss two problems of today's Lead Code Weekly Contest 3 to 1. So I am going to discuss the third and fourth problem. Let's first look at the third problem. The third problem. What is the third problem? It says that you are given the head of a linked list and you have to remove every node which has a node with a strictly greater value anywhere to the right side of it. Return the head of the modified list. So basically in this list, for each node, whatever is the right side, if the right side has a strictly greater node, or the right side has a node which has a value of strictly greater than the current node, then we have to delete the current node. Here in this sample test case, you can see that we have this linked list 5 to 13, 3 and 8. Now 3, the right side of 3 has 8 which is greater than 3, right? So 3 is deleted. Then the 13 has, the right side of 13 is 8, right? So let me just draw this for you. So let's say the linked list that I have is 5 to 13 3 8. Okay, so 5 to 13 3 8. Now you can see that the right side of 3 has 8, so 3 will be deleted. The right side of 13 is 8. uh, so the right side of 3 was 8, the right side of 13 was also 8, which is not strictly greater, so it will not be deleted. The right side of 2 has 13 and 8, so 13 is strictly greater and 8 is also strictly greater, so 2 will also be deleted. The right side of 5 is 13 and 8 as well, so that is also greater, so 5 will also be deleted. So the resultant linked list that we will have is 13 and 8, right? So what it says is that you can see that for any node, right, whatever is the result linked list, for any node in the result linked list, the right side will always have the nodes which has a lesser value, right? It can never have a greater value. It means that the linked list will have a monotonically decreasing sequence, right? The linked list, the values of the linked list will monotonically decrease. So this is a classic problem to use a monotonic stack, right? So what monotonic stack does is it keeps for an array or for any sequence of numbers, you can use monotonic stack, and using monotonic stack, the monotonic stack always keeps the values of that sequence in a particular monotonic order. It can be a monotonically decreasing order or monotonically increasing order as well, right? So here we will use monotonic stack to keep the values as monotonically decreasing. So if I have to show you my solution, give me a second. So here you can see, sorry, here you can see that I have taken a monotonic stack image, right? And what I am doing is I am simply traversing the linked list in this loop, in this first while loop, and then for a particular node I am checking in the stack that if stack is not empty and the topmost value of the stack is, so basically monotonic stack, because monotonic stack always keeps a decreasing order. Okay, so the topmost value we are checking, that if the topmost value is less than the current node's value, that means that topmost value has to be deleted, right? Because I'm going from left to right. So for the current head value, right, for the current head value, there is one value at the left which is in the stack which is less than the value of the current value, right? So that node, the left node, has to be deleted. So I am just popping it out from the monotonic stack until I am reaching a point where either the stack is empty or the left value of head is greater, the left topmost value of the head is greater. Now because monotonic stack always keeping a decreasing order value, So for the stack, if the topmost value is greater than the current head value, it is guaranteed that the values that are below that below the top value, is also greater, because it's decreasing from bottom to top, right? So that's why it is always increasing order from top to bottom. If the top is greater, so the bottom, like the values that are below top, are also greater. So then I am pushing the current value, and then I am just moving. So I am just doing this. Now once that is done, I have just kept a reverse taken a reverse stack, and I'm just, so because the linked list, the resultant linked list will be from the bottom of the stack of this ms, from the bottom of this ms to the top of the ms, right? And stack in stack, we know that we can only traverse from top to bottom. So I'm just keeping a reverse stack and pushing it to reverse the stack, just to reverse the stack, and then just forming the linked list as usual. It's very easy. I think you will understand it by on your own, right? And returning the head, that's it. So it's a classic monotonic stack problem. Now for the fourth problem. Okay, so what fourth problem says is that you are given an array nums of size n, which consists distinct integers. So this is one important observation. It consists distinct integer, and the integers are from 1 to n, and there is a positive integer k which is also given. Okay, and we have to return the number of non-empty subarrays in nums that have a median equal to k. Okay, so non-empty subarrays in nums that have a median which is equal to k. The median of an element of an array is the middle element. Cool, that's very, we know the definition of median. Okay, and for even length, the median is the left middle element. Okay, for example, the median of 2 3 1 4 is 2, and median of distance. Okay. So here you can see that for 3 2 1 4 5, where k is 4, so this is the element that we want as median. The subarrays that have a median equal to 4 are 4 4 5 1 4 5. Okay, 4 4 5 1 4 5. Okay, so okay, give me a sec. So first of all, because so one observation is it has distinct integer, right? It has distinct integers, right? And we are given a k, right? So for k to be a median, so let's say there is an array of elements, and somewhere in between there is one element k, right? So if k has to be a median, then whatever is a subarray, the subarray has to be including k, right? The subarray has to be like this. So if the starting of subarray and ending of subarray is en, then obviously starting should be less than or equal to the position of k, and ending should be greater than or equal to position of k, right? Basically the subarray must include k, otherwise there, like we can't have the PPM. This is one observation, right? Similarly, all the elements are distinct, right? It means that except k, if I take this part, right, this part, or if I take this part, whatever is the part, the elements that are there in this part, either the elements will be either greater than k or less than k, right? Now see, for let's forget about this problem. Let's just think about only the median part. So if we have a sequence, right, let's a sorted sequence, right, and there is a median here, right? What does it mean? It means that the number of elements on the left side of median is equal to the number of elements to the right side of median. L is equal to R, and all L elements are smaller and all other elements are greater. I'm just taking a increasing sequence, right? We can take decreasing sequence and the equation will be same, right? It will be just greater and smaller. That's okay. So this is the case for even, for odd, and for even you can see in the problem statement we have seen that we have to take the left middle element. It means that For even, how will be the sequence? The sequence will look like this, that there are some elements, let's say L, then there will be K and there will be R, right? And this amount will be same, right? So L plus K should be equal to, sorry, L plus 1 is equal to R. So L is the number of elements to the left of the K, and the K included itself to the left side, and then the R is the right side, right? So if we include K in the left side, then only K will be the median. So these two are the possible conditions, right? And these L are smaller, right? And so now let me just tell you the solution. You will understand what I'm trying to say, right? So what we can do is, you can see that to the left of this K, we know that there will be only some greater than element or some less than K element, right? Let's say that to the left of the K, the elements, the amount of elements which are greater than K are, let's say, B of L, let's say, okay, B for big and S for small, right? Let's say B of L and L for left and R for right, okay. And the element that are less than K are S of L, right? So to the left side, the element greater than K is B of L, the element less than K to the left side is S of L, okay. Let's just say. And to the right side, the element greater than K is B of R, the right side elements less than K is S of R, okay. So now if I take this sequence, right, what this sequence has, this sequence has 1K element, some elements to the left which has B of L, some elements to the right which has B, which is bigger than K, some elements to the left which is smaller than K, some elements to the right which is smaller than which is smaller than K. Now this sequence, it has this many elements, and if we try to find the median of this sequence, then we'll sort this, right? So the sequence will arrange in such a way that all the small elements to the left of K and all the bigger elements to the right of K, right? So there will be some SL, then some SR element, then there will be K, then there will be some BR element, then there will be some BL element. This is the sequence, right? Mind it, SL is the size, right? So SL have some X amount of elements, 1 2 3 something, like some amount of, SL is the number which is not the number, like, so there will be SL amount of elements here, SR amount of elements here, 1K, BR amount of elements here, BL amount of elements here. So for K to be median of this sequence, from these conditions, these two conditions, what should be the case? If let's say it's odd, then SL, sorry, okay, so then for this one, say SL plus SR should be equal to BR plus BL, correct? And if it is odd, if it is even, then we know that what L plus 1 should be equal to R. So L is SL plus SR here. So SL plus SR plus 1 should be equal to R, that is your BR plus BL, right? Now if I'm just like changing the equation, you can see, so I'm taking all the left side to the left, okay. So SL and here is BL. So for this equation, okay, for this equation, if I change, we'll have SL minus BL, right? SL minus BL should be equal to BR minus SR, correct? And this equation, SL minus BL, I'm just taking this BL to the left, plus 1 should be equal to BR minus SR, so BR minus SR. So if these two conditions satisfied for all the indexes, so if this condition satisfies, if any of these condition is satisfied for the particular sequence, then we can say that K will be median of that sequence, right? So what we can do is, for each index I can store this element. So for L is what, from the index of K, the left, right, from this part is the this part contributes to SL and BL, right? So what I can do is, I will start from this index I'll go to the left, okay, and I can easily check what is the SL and BL for a particular index in order of n time. And what I'll do is I'll store that those elements, okay. So SL minus BL, I'll store the value of SL minus BL, I'll store with its frequency. Similarly, I'll go from this to the right and I'll store this value. So for each index, I'll store BR minus SR. Okay, I'll store the frequency with the frequency. Right now, all the indexes that, let's say there are the frequency of SL minus BL is X, means for X indexes to the left of K, for X indexes to the left of K, the value is SL minus BL, which is some value, let's say Y. So similarly, K, for K to be median, we know that this value should be same. So we'll just check that to the right of X, which is BR minus SR, right? How many values are Y? So let's say the Y value has a frequency of X2, let's say X2, right? So you can easily say that for each index of this SL minus BLX, we can take the element to the right, we can take the indexes to the right which has the same value as BR as SL minus BL, which is Y. So we can take X2. So this will be the number of sequences that we can have with median K, and the sequence size will be odd. Similarly, for even, we can just check that if if the, let's say SL minus BL is Y, then we will check that for how many indexes to the right we have a Y plus 1 value, and whatever is the number, whatever is the frequency, we can just multiply that, those two. That's it. That's what we have to do. So now let me go through the code. So you can check here. First, I have found out that what is the index, like what is the position of K, right? Once we know that this is the position of K, so this index represents the index of K here, right? Then we have taken two map M1 and M2. So basically M1 will have so okay, let me just edit this code. Give me a second. I guess because of contest it is not enabling editing. Okay, so M1 has SL minus BL. Okay, M1 has this part SL minus BL, and M2 will have BR minus SL. Okay, so I have taken B0 S0, and then from index I plus 1 to n, means from this part I'm from going from left to right for now. So I'm going from index plus 1 to n, and just simply that if nums of I is less than k, increase the small amount like s, it is SR, and if nums else increase the b, right? And for the right part, what is the equation? The equation is BR minus SR. So I'm just increasing BR B minus S here. The frequency of B minus S is increasing in the M2 map. Similarly, I am again initializing S and B as 0, and I am going from left to right. Sorry, right to left. Okay, from right, from the left of the car, I'm going from right to left. Okay, and similarly, I am updating S and B, and in the map M1, I am increasing the frequency of S minus By, because from the left we have the equation SL minus BL. Right, and I am also increasing this part because so 0, what 0 indicates? 0 indicates that there is nothing in the left, and so here we have considered that at least there is something in the left and right. So because I am not considering that part, that there is nothing in the left, nothing in the right, so I am just increasing, like keeping 1 as 0 in both the maps. Okay, then the stand size will 0, it's okay. Then what I'm doing, I'm traversing the M1 map. So I'm traversing all the values of SL minus BL that I have inserted into M1, and so let's say V is the value. So V has SL minus BL. B is this SL minus BL. This Y is V, right? So for each V, what I'm checking, I'm checking that if M2 is like M2 has V or not. If has V, then IT dot second means M1 of V1, M1 of V, right? So SL, the frequency of SL minus BL is this, and the frequency of BR minus SR, which is equal to SL minus BL, is M2 of V2, M2 of V, right? So all those indexes can pair with each other, right? So it's like let's say the frequency of SL minus VL is F1. Let's say the frequency of SL minus VL is here, let's say F1, and it is F2. So obviously, what is the frequency? F1 C1 into F1 F2 C1, right? Any index of this F1 or any index of this F2 will be paired. So F1 into F2. Similarly, so this will give us the odd sequence or the length sequence, and for even length we know that what is this this V plus 1, SL minus BL plus 1. So V plus 1 I am checking if this is present in M2, and if this is present in M2, then I am just multiplying the again the frequencies, correct frequencies, right? And then just redundant. So that's it. That's how we will solve this problem. I'll link this codes in the comments in the description. If you need, you can check it out. Okay. Thank you for listening to me for this long, and give me the feedback if you like, whatever feedback you want to give. Thanks.